So I did an example for 2 different zones on this. This is, we have to calculate diversity for this last one. Again, we're using Simpson's diversity. So basically trying to figure out if one zone is more diverse than another. So you think that the cattail zone has the least diversity, or maybe the shrubs and the tamarack forest have the most diversity. Basically, we're going to make a bar graph again. Yeah, but we have to calculate the diversities first. So let's talk about calculating the diversities, because that's kind of the hard part. We did this at the Indiana Dunes. Again, you have to organize your data. Organizing your data for this section is really important. So what I did was I basically just imported everything from this diversity 1, copied this whole thing, and then I pasted it here. So that's the same. And then I sorted by quadrat. You guys remember how to sort? Right? So if you just take this whole thing, data, one custom sort. Okay, how do I custom sort? Can we say that and see what happens? Yeah, cool. So I want to sort by quadrat, so I have everything, all the stuff that I wanted to measure in the same place. So you just go to the quadrat, and then you next. So then you have quadrat 1, quadrat 2, and all your species organized per quadrat, right? The reason I did that is because you have to calculate the proportion in each quadrat. So if you recall from the Indiana Dunes one, what you do is you take all your species and you put them in rows. So that's another reason I did it like this, because I want all my species, like, I want 1, 1, 2, 2. I wanted all my species separated. And then, you can just copy, since I have my stuff sorted now, I can just copy all my stuff from quadrat 1, these 4 numbers over to quadrat 1, and then these 4 numbers for quadrat 2 over here. Is that clear? And so now I have my little table that was very similar to the one that I did for the Indiana Dunes report. It's in the same format as that table was. And remember, for that, we had to find the proportion of each species in each quadrat, right? And to do that, you need to find the total number of each of total species. Because we're trying to find the proportion of this species relative to all species in that quadrat, right? So we take this number and divide it by this number to get the proportion. Recall that in Simpson's diversity equation, you square that proportion, right? This is exactly what I did in Indiana Dunes one. So in these fields over here, I have proportion in quadrat 1 and proportions in quadrat 2 squared for each of these different species. So that's what this one is. This first part is 10 over 43, which is the proportion of grass 1 over all the species, and I squared it. So that's the equation. The reason I put those dollar signs in there in front of I and the 9 was so that when I had this, I could just take this little guy and drag it down, and then I9 stayed the same for all these, but the other one moves. So you notice the one in blue moves, but the one in red doesn't. See that? It's just a little trick to like help you save some time. But basically for all these, it's the number of this over the total squared. And the same thing for quadrat 2. Cool? You have all those proportions squared. Now you can calculate the diversity in each of those quadrats. Right? So that's this d value is. And if you recall, the equation for the diversity is 1 over the sum of the proportion squared. So we have all of our proportions squared already in that quadrat. So we take 1 over the sum of all of our proportion squared values. Is that cool? Now I do the same thing here for proportion 2, or for quadrat 2, sorry. 1 over the sum of those proportions squared. And now that we have two numbers, two diversity numbers for that zone, we can get an average diversity for the entire zone. Now there's a little note here that says there's only 2, and ideally you want 3 for any kind of sound statistics, but we only took 2. So we're going to work with that. But just for future knowledge, it's not recommended to take averages and standard errors and standard deviations on a replica of 2. It's just not a good representation of the data. 3 points is minimum. So if you're designing an experiment, always design at least 3 replicas. Okay? Anyway, we have 2. So you take the average of those 2 diversity values and the standard error of those 2 diversity values. Again, square root of 2 here, so there's only 2 numbers. And that gives you your average for that zone, right? So this is zone 1, I just did. And one little trick I'm going to show you to maybe save you some time. I should have showed this to you last time, I don't know why I didn't. But you can literally copy all this. I just put it somewhere else. So as long as you keep your labeling right, like you want to be like, all right, this is now zone 3, or I'm sorry, no, it's okay, never mind. So you can, as long as you keep track of kind of what you're working with, you can then just go and change your numbers in here. And as long as you have all your equations set up correctly, it should adjust all this stuff for you automatically. So you notice how the d values are different and standard is different. So if you want to mess with that, you can just copy and paste all that so you can type it all out again and then just put in the new values, the new raw values. As long as your equations are set up correctly, it should work. If you do that, I make sure it's the first time you do it that it's working correctly. Go and through it thoroughly and check and make sure that everything is what it should be for your values. So yeah, notice how this changed. No, they didn't. So something I did was wrong. But yeah, you can do that. I've done it before.